Hello and welcome to this GCSE Science Additional Physics revision video on current electricity. In this video we will look at electric charge and static, electric circuits, resistance and series and parallel circuits. In the first section of this, looking at static, it's important to remember that in the exam they can talk about static in a number of different ways. The key point to any question about static is that you are always talking about the movement of charge. Remember that things can either gain electrons or lose electrons. You can't gain or lose positive protons. If you gain negative electrons, it will become negatively charged. If you lose negative electrons, it will become positively charged. Good conductors, such as metals, allow an electric charge to pass through them, but insulators, such as plastic, do not. A substance gains electrons and becomes negatively charged, while another substance that loses an electrons becomes positively charged. You can get an electrostatic shock if you are charged and you touch something that is earthed, or you're earthed and you touch something that is charged. Metals are good conductors, which means that electrical charges move through them easily. Materials such as plastic, wood, glass and polythene are insulators. This means that they do not allow electrical charges to move through them. Some insulators can become electrically charged when they are rubbed together. So, in an exam, it might ask you how we can tell if something's been charged. If a plastic rod is rubbed with a duster, it attracts small pieces of paper. If a balloon is rubbed on a jumper, then it can stick to the wall. Some dusters are particularly designed to attract dust. In all three of these cases, it's because they've become charged, so will attract oppositely charged materials or materials with no charge to them. Objects can be positively charged, negatively charged, or neutral. A substance that gains electrons will become negatively charged, while a substance that loses electrons will become positively charged. When a charged object comes near another, the objects will either attract or repel each other. If the charge is the same, then they will repel. If the opposites are different, then they will attract. If one object is charged but the other is not, it will attract. Always remember, opposites attract. You can get an electric shock if you are charged and you touch something that is earthed. When people walk along a vinyl floor or one covered with a nylon carpet, you can charge up because of friction. You can earth yourself and get an electric shock by touching a metal door handle or a water pipe, for instance. There are a number of problems with static. If something becomes statically charged, it can attract dust or something to it. Or, if something's statically charged, then it can cause a number of dangers. There are inflammable gases or vapours of high concentration of oxygens which a spark could ignite. If you touch something with a large electrical charge on it, then the charge will flow through your body, causing an electric shock, which could also stop your heart. So, it might in your exam talk about safety measures to do with static. Right, the three main ones that you could be asked about are an object that might become charged is connected to the earth by a wire, so the charge immediately flows down into earth. In a factory, machinery operators stand on insulating mats and wear shoes with insulating soles. This stops the charge flowing through them to the earth. Lorries containing inflammable gases, liquids and powders are connected to the earth by an earth wire before being loaded. This means charge immediately flows to the earth, which prevents a spark which could cause an explosion. With electric circuits, you need to know and recognise a number of different symbols. Electric circuits can be represented by circuit diagrams. The various electrical components are shown by using standard symbols in the circuit diagram. Components can be connected together in series or in parallel. The characteristics of the current and potential difference, which is the voltage, are different in series and parallel circuits. When drawing circuit diagrams, there are two important things that you must consider. There must be a complete circuit, and there must also be no short circuits. So remember, when you're drawing it, do not leave any gaps or check for gaps, as this could lose you easy marks. To check for a complete circuit, follow the wire coming out of the battery with your finger. You should be able to go out of the battery and through the lamp in one case, and then back to the battery. To check for a short circuit, see if you can find a way past the lamp or whatever the component may be without going through any other components. If you can, then there is a short circuit and the lamp or component will not work. Remember that electric current is the flow of electric charge. No current can flow if the circuit is broken, for example, when its switch is open. This diagram shows a circuit with an open switch, so therefore no charge will be able to move around. In a circuit, we can measure the current in amps and the potential difference in volts. Current is measured in amperes or amps. The current flowing through a component in a circuit is measured using an ammeter. An ammeter must always be connected in series. Potential difference is measured in volts. The potential difference across a component of a circuit is measured using a voltmeter. This must be connected in parallel to the component. The current flowing through a resistor at a constant temperature is directly proportional to the voltage across the resistor. So, if you double the voltage, the current should also double. This is called Ohm's law. The formula for resistance is equal to voltage divided by current. There is a resistance to the flow of an electric current through most conductors. The resistance in a wire increases as the length of the wire increases and the thickness of the wire decreases. An electric current flows when electrons move through a conductor such as a metal wire. The moving electrons can collide with the ions of the metal. This makes it more difficult for the current to flow and causes resistance. The resistance of a long wire is greater than the resistance of a short wire because the electrons collide with the metal ions more often. The resistance of a thin wire is greater than the resistance of a thick wire because a thin wire has fewer electrons to carry the current. The graph above shows how current can be plotted against voltage. Using a graph like this, you can work out what the voltage is for a given current, then using the previous equation for resistance, you can work out the resistance of that particular component. So for instance, when the voltage is 2 volts, the current is roughly 20 milliamps on this graph. The filament lamp is a common type of light bulb. It contains a thin coil of wire called a filament. This heats up when an electric current passes through it and produces light as a result. The resistance of a lamp increases with the temperature. The current flowing through the filament of the lamp is not directly proportional to the voltage across it. This is because as the temperature increases, the metal ions vibrate more vigorously. As the metal ions vibrate more, they cause more resistance to the electrons, as the electrons are more likely to hit them. The graph to the right hand side shows what the potential difference or the resistance looks like in a filament bulb. Diodes are electrical components that can be used to regulate the potential difference in circuits and to make logic gates. The diode has a very high resistance in one direction. This means that current can only flow in the other direction. To the right is the graph showing the resistance in a diode. The LED is another component which you may be asked about. A light emitting diode produces light when current flows through it in the forward direction. LEDs are often used for indicator lights in electrical equipment such as computer and television sets, as LEDs use a much smaller current than other types of lights. They are more efficient. Thermistors are used as temperature sensors. For example, in fire alarms, their resistance decreases as temperature increases. At low temperatures, the resistance of the thermistor is high, so little current can flow through them. At high temperatures, the resistance of the thermistor is low, so current can flow through them, and in the case of fire alarms, cause the alarm to go off. Light-dependent resistors are used to detect light levels, for example in automatic security lights. Their resistance decreases as the light intensity increases. So, in the dark or at low light levels, the resistance of an LDR is high and little current can flow through it. In bright light, the resistance of an LDR is low and more current can flow through it. This causes the current to increase at lower levels, which turns on the light. In a series circuit, at all points of the circuit, the current remains the same. However, the voltage is split over the two components. So if you know that the current is 1 amp at one point, then the current will be 1 amp at all other points. If you know in this example that you have 6 volts coming out of the power pack, then over two different components, that 6 volts must be split, giving each component 3 volts. If we know this, we can calculate the total resistance in that circuit. We start out by working out the resistance for the individual components using the equation resistance is equal to voltage divided by current, and then adding them together. So in this example, we're going to do 1 divided by 3 plus 1 divided by 3. So the total resistance will be 0.66 ohms. Have a go at working out the resistance is shown in the red box below. In a parallel circuit, we are quite often asked to calculate the total current. We do this using the following series of events. We know that current is equal to voltage divided by resistance. So we need to go and work out the current flowing in each of the different arms of the resistor. So we're going to have along the second arm 6 divided by 1 plus 5, because 6 is the amount of voltage, and the total resistance along that single arm is 1 ohm plus 5 ohms. In the first arm, we're going to do 6 volts divided by the resistance, which is 3, giving us 2 amps. To work out the total current, we add those two values together. Remember, when revising, start early, turn off any distractions, and when working through physics equation questions, it's important to keep practicing them. Good luck with your physics exam.